In a chemical reaction, it often happens that one reactant will run out before the other. This is called the limiting reactant. It's a reactant that runs out before the other, and it stops the reaction in its tracks, limiting how much of a product can be made. There's also going to be something called the excess reactant, which is how much is left over, or the reactant that's left over after a reaction is complete. And then at the end, we're going to discuss in this video how to find out the percent yield of a reaction, and we'll just talk about what that is in a bit. So just like in regular life, like imagine you're making a sandwich, and if it's got ham and if it's got bread, when you get to the end of your ingredients, you're either going to run out of ham or bread first. It hardly ever happens that you have exact amounts that you need of both. So same idea, we're going to use that idea in chemistry. So taking a look at this first example, so let's say we've got two reactants here listed that react in this way. Okay, we have so many grams of ammonia, and we have so many grams of copper oxide, which is the limiting reactant, and then how many grams of N2 are formed. Okay, so we're going to walk through how to do this problem. There are 4 steps to doing limiting reactant problems. The first step is to make sure that the equation is balanced. And in this case, I think we are not quite balanced yet. I'm going to follow the rules I taught you guys for balancing. So let's see, I'm going to do my nitrogens first. I look like I need a 2 here. And then my coppers. It turns out I'm going to need 3 of each, actually. And this will be made clear here because if you guys notice, we got 2 times 3, that's 6 hydrogens, so we would have needed a 3 over here, and I think that balances us out. So that's step 1, is make sure your equation is balanced. Step 2, and this will make more sense when you see the actual reaction done out, but we're going to pick one product, and in this case, the problem mentioned that we're solving for N2, so that's the product that I'm going to be solving for when I do these problems. And then the next step is to do 2 stoichiometry problems. So what I'm going to do is I'm going to start with the 18 grams of ammonia and figure out how much of my nitrogen I can make. And then I'm going to start with the 94 grams of copper oxide and figure out how many grams of nitrogen I can make. And then we're going to compare our answer. And then the answer, or the reactant that made the least product, is going to be called our limiting reactant. It's the one that will run out first. So what does this actually look like? Let's walk it through. So like I said, we're going to pick nitrogen to solve for because that's what the question is asking about. And we're going to do 2 stoichiometry problems. I'm going to start the first one with the copper oxide. So 94 or 90.4 grams of copper oxide. And I'm going to do a stoichiometry problem solving for grams of nitrogen. So if you're still a little shaky on stoichiometry, make sure you're using the roadmap that I've taught you guys how to use before. So we've got, let's see, 1 mole of copper oxide. The first thing we have to do is turn this into moles. So the molar mass of copper oxide is 79.55 grams. The next step is to use our mole ratio. So taking a look, we have 1 mole of nitrogen for every 3 moles of copper oxide. So remember, it's want over have. So 1 mole of nitrogen over 3 moles of copper oxide. And the question was asking how many grams, so I am going to take this one step farther and I'm going to solve for grams of N2. So 1 mole of N2 has a molar mass of 28.02 grams. All right, dividing by, so 90.4 divided by 79.55 divided by 3 times 28.02, that gets me 10.6 grams of N2. So that's how many grams of nitrogen could be made with our copper oxide if I had unlimited amounts of the other reactant. Okay, now we're going to do the same thing, but we're going to start with the ammonia instead. So we've got 18.1 grams of ammonia. And again, we're going to be solving for the nitrogen, so we're going to use the molar mass. 1 mole of ammonia. And then the mole ratio, this one is a 1:2 ratio. So we've got 1 mole of nitrogen for every 2 moles of ammonia. And then lastly, again, we're getting into mass, right? We need mass of N2 that we can be produced. So 1 mole of N2 weighs 28.02 grams. Okay, crunching this stuff out, we end up getting 14.9 grams of N2. So here's the deal. This is step 4. We're gonna compare our answers, okay? So the part, or the reactant that made the least amount of product is the limiting reactant. So obviously this was the smaller amount right here, so this is how much of our nitrogen we can make, okay? And the limiting reactant is the copper oxide, okay? So that guy, we call it LR, limiting reactant. So it's important first, yes, it's important to know how to do the math, right? How to crunch these numbers. But remember, why are we doing these? What is this math showing us, right? This math is telling us that if I start with unlimited amounts of my other reactant and I react all of this 90.4 grams of copper oxide, the most product I could make is 10.6 grams of nitrogen. Same idea here. If I started with 18.1 grams of ammonia and had unlimited amounts of the copper oxide, I would be able to make 14.9 grams of nitrogen. So comparing our two answers, the smaller amount is what can be made. Just like if you have like, I don't know, 10 hot dog buns and only 4 hot dogs, right? You can only make 4 complete hot dogs. You couldn't make 10. So that's the idea, is the smaller number is how much is actually produced, and then whatever made that is the limiting reactant, okay? Common mistakes that people will make is that they will take these answers and they will add them together, and they will say that we can make whatever, 10.6, so like 24 grams of nitrogen can be made. That is false. Do not fall into that trap. That is not how much can be made. Only the smaller amount is made. And another mistake that people will make that drives me crazy is they will circle this answer and they will say nitrogen is the limiting reactant. Don't be one of those people. Remember, nitrogen is a product. It can't ever be a reactant. So make sure you're tracing back to the actual reactant that made the smaller product, and that's your limiting reactant. Okay, so now that you guys have seen one practice problem, I want you to try the next one out. This one's just the same kind of idea. We've got 2 reactants. We've got a certain amount of product that we're interested in making, or we want to see how much of our product we can make. So go ahead and follow those steps, and then pause the video, try it on your own, and see if you guys can get the correct answer. Okay, let's see if you're ready to see the result. So did you remember to balance the equation before you started? I hope you did, because there was a 2 that needed to go there. Okay, now let's keep going with our steps. So I'm going to start with the magnesium. I've got 5 grams of magnesium. Again, I'm going to be solving for the product. In this case, it's going to be the MgCl2. It's usually a good idea to solve for whatever product they're asking about in the problem. If they don't give you a product to solve for, you can just pick either one and it will still lead you to the correct answer of what the limiting reactant is. So, all right, 1 mole of magnesium is 24.30 grams. We again are solving for MgCl2. That is a 1-to-1 ratio. So 1 mole of MgCl2 and 1 mole of Mg. And then we've got 1 mole of MgCl2. Now I'm turning my product into grams, 95.21 grams. So the magnesium can make 19.59 grams of MgCl2. Let's see how much the HCl can make. So again, the HCl is 6 grams. And again, then we have to turn it into moles first, so we're going to divide by molar mass. The ratio here is a 2-to-1, so there's 2 HCl's for every 1 MgCl2. Remember, it's want over have though, so MgCl2 goes on top. And again, we want it to get into mass, so 1 mole MgCl2 goes on the bottom and 95.21 grams goes on top. All right, so in this one, if you crunch the numbers out, we get a way smaller number, 7.83 grams of MgCl2 can be made. So that means then, firstly, that we can make this amount of our product, not them added together, but just the smaller amount of product is made because we're going to run out of hydrochloric acid. So we're going to run out of HCl. So this guy is our limiting reactant. So basically this means when 5 grams of magnesium reacts with 6 grams of hydrochloric acid, the hydrochloric acid eventually runs out and we stop the reaction. And when we stop the reaction, we will have seen that 7.83 grams of magnesium chloride were produced. Okay, so that's what that means. I hope this makes sense. I'm going to pause the video or stop the video now before you guys move on to excess.